Good morning, students. Today we're going to be working on applications of quadratic functions. One of the most common applications of quadratic functions is projectile motion. And projectile motion is when you shoot objects into the air or through the air, and we can model them with parabolas. In these functions, the height is going to be your dependent variable, and the independent variable is going to be time. Even if the object is shot straight up into the air, the graph is still going to appear to move forward because time is always moving forward. Every object in projectile motion has the same force that's going to be acting on it, gravity. So you're going to see these numbers appear over and over again. Negative 16 refers to when it's in feet, and negative 4.9 is the gravity coefficient in meters. So this is the problem that we have. A water balloon is launched straight up. The balloon's flight can be modeled by this function. Notice that what we have is it equals height. This is your square term, and this is your linear term. There is no constant. H of t is the height, t is time in seconds. We're going to answer the following questions graphically and algebraically. So we're given this graph. We're given this graph, and they can ask you several questions here. So what you need to understand is that this is your x-axis, and this is your y-axis right here. This is time equals 0, and then on the blue is where you get the height. So let's say they ask you the first question, at what height did the water balloon start? Where you start at time equals 0. So you go looking at time equals 0. What was the height? The height was 0 feet. The next question that they can ask you is, when did it reach the maximum height? Well, the maximum height is going to happen at the vertex. At what time did it reach the maximum height? At time equals 6 seconds. What was the maximum height? Well, the maximum height is going to be the y value of your vertex, or 576. When did it hit the ground? Well, this is the water balloon going up, and this is the water balloon going down. So it hits the ground here when the height equals 0 again. And the height equals 0 again at 12 seconds. So graphically, if you know how to read the graph, this is pretty simple. Very easy to read. Now you also have to learn how to do this algebraically. So we don't have the graph, okay? So you need to understand that we don't have the graph. So what height did the water balloon start? Well, we know the water balloon started at t equals 0, right? So we need to plug in 0 into the function. So what was the height at 0? Negative 16 times 0 squared plus 192 times 0. This goes to 0, that goes to 0. You can put it in your calculator. You get an answer of 0. So the height was 0 feet at time equals 0. When did it reach the maximum height? Well, what they actually want you to find here is negative b over 2a. So when you look here, since this is the square term, a equals negative 16, and this is your linear term, b equals 192. So this is negative 192 over 2 times negative 16. And you actually get a height of 6. So at 6 seconds, you get a time of 6. 6 seconds is how long it took to reach the maximum height. If they ask you what was the maximum height, well, then you need to plug in this time, the negative b over 2a result, into the function. So we want to find the function at time equals 6 seconds. Using your calculator, you're going to get 576. So the maximum height happens at 576 feet. When does the water balloon hit the ground? Well, the ground is considered to have a height of 0 in this problem, right? So we know that h of t equals 0. So you're basically setting the function equal to 0. 0 equals negative 16t squared plus 192t. At this point, I think it might be best if you use the quadratic formula. So it's going to be negative b. B we said was 192 plus or minus the square root of b squared minus 4ac, c is 0, so then c equals 0, forgot to mention that, over 2 times a. And when you type this into the calculator, and I recommend that you do, we get two answers. We get t equals 0 and we get t equals 12. Now we know it's not t equals 0 because that's when it started, so it has to be 12. So it hits the ground 12 seconds after launching. What was its height at 9 seconds? Well, here they're telling you that the time is 9 and they want to know what was the time, what was the height at 9 seconds. So you literally have to plug in 9 for t. So h of 9, negative 16, 9 squared, plus 192 times 9. You type this into your calculator, and you get a height of 432 feet. Okay. Now, looking at the graph and considering the real-world context of this problem, we want to select the appropriate domain. So now let's think about it. We have a water balloon that is launched straight up, and it goes up in the air, and then it lands on the ground. Let's talk about the domain is going to be the time that is involved, right? This has nothing to do with height. It has to do with the time. For which times can we consider this water balloon being launched and landing on the ground? The first thing you need to understand is that time can't be negative. So you're going to start at time equals 0. The water balloon is in the air, maximum height is coming back down, and then it hits the ground. It's not going to go past the ground, right? It's just kind of going to remain there. So time equals 12 seconds is when it hits the ground here. So the domain, or the valid time values for the flight of this water balloon, is the starting time and the time when it lands on the ground. So between 0 and 12. So which of these talks about it being between 0 and 12? This one.